computer is in this control, but I don't have a screen capture program in the control itself, so we're just going to have to make do with recording the screen from the camera here. So this is the program for to regrind this drill. Let me just run through the simulation real fast. And this is going to look a little bit strange because there is no flutes in this blank that is showing here, because we're just regrinding the tip. But let's just start it and I'll show you what it looks like. See, it says it gets a collision right there because there's no flute in it. But this is what the grind's going to look like on this drill. What we're going to do, let's show you what the program looks like. It's pretty simple to program a drill or even an end mill or anything on this machine. You just got to select the appropriate cycle. Actually, let me go back to here. These are the particular I don't know what you call it, softwares. You can have more modules, I guess you might call these. On my machine, I have end mills, form cutters, drills and step drills, and burrs. I've never ground a burr, so I don't know how that works really. I've never done that before, but I have used all these others here. And you can do an awful lot with these three modules in this software. That there's a whole bunch of settings in here. And these other icons up here on the screen have to do with the wheels and the wheel packages. You can have multiple wheels on one spindle, which is the way you grind end mills actually. You'll have a fluting wheel and a gashing wheel and a cup wheel that you do the cutting edges with. But in the case of this drill, we only need this one grinding wheel that I was dressing in the video here. And the way this works is you have to have a geometry set up, and they call it this step one, which is basically the tip and everything back from the tip if you don't have more than one step. And these are the dimensions of this drill, which you just give it the diameter and the length of the flute if you're fluting. But this comes into play when it probes it too, so you kind of got to give it a length here. And there's no taper to the drill. The geometry of the drill itself is what this all amounts to. And the point over here, which I'm calling it 135 degrees, you can see this little icon over here that comes up that kind of describes these certain settings here. So that's the 135 degree point. And you can select different styles of points for this. If we wanted to change it, we could select this. See, it's calling this an M6. I don't know exactly what that means, but this is usually the tip I use on my drills. But you can select all these points to do. You can do just a regular spiral point, a 4-facet, S4, S6, M6. I'm not sure. This one obviously doesn't have a primary and secondary clearance like these two do. And these ones that are not in black I can't use because I don't have that part of the software, I guess. Then you can have this, and I've used this before. This is a 3-flute tip that comes to a sharp point basically here. And they call this a beak point, which you see sometimes on woodworking type tools. And then an end mill style, which is just like an end mill's tip. And then this SP3, I've never used this one before, this SPV. Countersink I've done, and I've never used this SX one before, but all the rest of these I've used in one way or the other, except for the ones I just said. But we're doing this on this drill right here. I can't really tell the difference between this S6 and this M6. They're so close to being the same, it's really hard to tell the difference. But we're putting the M6 on this drill here. This is the one I've used before, and it seems to work pretty good. So you actually define the point and the angle, and then And then the step dimensions, like I've already showed, which is the diameter of the tool and the length of the flutes. And if you had a taper to it. And you can put down here, you can put a chamfer, which I take would be a chamfer on the tip here if you wanted that. So that's the dimensions of this drill. And then you can specify the flutes, helical, straight, left, right. You can have a cutting direction of a right-hand drill but have left-hand flutes too. You can do both directions there. The lead of the drill. This actually came, I've already ran one tip of this, and it actually came up from the probing cycle, which you'll see in a second here. And then the core diameter, and if there's a taper to the core, which I'm not specifying any of that because I'm not actually fluting this tool, so it doesn't really matter to me in this case. And these are the divisions. You could put an uneven spacing on this if you wanted to. Apparently, see, it probed, last time it probed the tool I already ran, it probed a slightly different spacing there. Simple as the program is actually on this, then you just have to, but you can define a whole bunch of stuff here when you get to the actual, it builds the program from that information as well as a little bit of this information. This is actually the setup on the machine. The drill itself is sticking out 1.6 inches from the collet measure, and I've measured from the collet here. And I happen to know the collets, all of these Schwablin collets run 5.8 inches from the spindle's face out on my collet chuck, and the diameter of the tip of the collet there. And then this information is going to be where it's going to probe it and where the probing distance back is. I just left that at the default, whatever it came up with. And these are the feed rates and the increments of cut. But I just leave this at the default pretty much. I don't really mess with that stuff too much. So that's the setup. The actual setup information is the machining, and the geometry is what we just looked at. And when you make all of that geometry and you say okay, then it generates these tool paths. It's called the gash out, the facet 1 and facet 2. And then you have to select a grinding wheel, which I've already selected here, which is the wheel I was just dressing to grind with. Because I just dressed it though, we got to do one more thing here. We got to actually probe it with the probe on the machine because it changed in size when I dressed it. So in order to actually probe a wheel, what you have to do is you have to find the wheel package it's on, which I happen to name this one Naxo 15 degree with, oh no, this one's a Naxo 1A1. That's the type of a wheel it is, a 1A1 wheel. I don't know if you can see that. This is the manufacturer of the wheel. This is the manufacturer of the wheel I'm using, and they call it a Naxo Force is their name for this particular type of wheel, this diamond wheel they make, which is I really like these wheels. They work good. You say open, and then down here there's a little cursor for probing, and you would select that, and it will give you the features you want to probe. We're going to probe the diameter, the face, and the width. We're not going to do the angle because this wheel is square. So you just say okay here. Excuse me, you don't say okay, you just say probing here. And it says there's no position because I didn't put it in there. So we got to go back. What it's saying is I have to have it mounted in the machine, or tell the machine it's mounted in there. Right now I've got a different one mounted in there. I was necking down some end mills. So I got to select that. Now it shows that in the spindle. This machine has a wheel pack changer, and you can put another one here, and if it shows it over here, it would go change to it, but we don't need to do that right at the moment. We're just using one wheel. So we go back here again, select the package, and it's this one, this 1A1, Naxo 1A1 I call it. We'll open that, we go to probing, and we select the probing button here. And now it's saying it wants to measure the wheel, but we have to push cycle start, of course, before it'll do it. So let me position the camera over here so you can see that happen. So it's gonna probe this on this probe right here. So this is kind of hard. Everything is blocking the view of this, but I'll start it and then I'll see if I can move the camera over to here so you can kind of get a better view of it. Maybe let me try and see. So I'm gonna push start. It's gonna square the B-axis. It's not quite square. Okay, and it's gonna start coming forward. Let me let it come forward a little bit. I'm gonna stop it right here. Over the front of the wheel up here. That squeaking noise you hear is the way covers. They're kind of squeak a little bit sometimes. Now it's going to probe the diameter of the wheel. Probes, it opens up this window to show you what it was before. The diameter was 4.8238 and now it's 4.8084, and the flange distance before was 3.0346 and now it's 3.035. That's a little odd that it would be longer before now than it is before. Maybe I wore off a little bit when I dressed it. And the width was 4.4626 and now it's 0.4615. So it's just a little bit narrower too. Maybe I did rub a little bit off when I dressed it with the stick on the faces a little bit. So you can just say, you can select OK here and OK there, and just close this out. Yeah, I can't really show you it grinding because of all the oil, but I'll grind it and then I'll run it dry, and I'll show you that afterwards. The only thing that you actually have to do to grind is you got to go up here to sharpen, because I made this a regrinding program. You can either have a manufacturing or regrinding. So I'd select this little icon for sharpening, and I could say probe and then grind here. It should be like this, and it's sending the program up to the control from the computer in the computer here up to the control in the machine, and it's telling you to start to actually start grinding. You got to push 2 cycle start buttons on this machine. See if I can direct the camera down there. See, they're right here. You got to push both of these to start at one time. You can't just push one and it won't work. I guess it's a safety feature or something, maybe, I don't know. So let me reposition the camera and I can show you the probing cycle with the coolant turned off. I can turn the coolant off here and you'll see how that looks. I'm going to slow the feed rate down so I can catch things. I can't really, I've got to close the door, as you'll see here in a second how much coolant and everything is going to